Okay, now a few more things about catalysts. Remember back in the last chapter, we talked about these equations that showed how much energy was coming off or going into a reaction. And we just told you last time that this amount here, it was called the activation energy. It's the energy to make the reaction go. A lot of reactions, the smaller this hump is, the easier your reaction will to go. We calculated the delta H from the beginning and the end of that, but now we're going to talk about this activation energy. How can we make our activation energy smaller? Well, in our lab this week, we talked about adding a catalyst. So what does a catalyst do? A catalyst works in one of two different ways, but what it really does is it lowers this activation hump. Speeds up the reaction because it makes it easier for the reaction to go. So a catalyst will lower the activation energy. But definition, a catalyst does not get used up in the reaction. So we are going to lower the activation energy without using up the catalyst. There's two different kinds of catalyst. A heterogeneous catalyst is just a different phase. So in our lab, we had a liquid hydrogen peroxide. We added in a solid yeast, and so that was a heterogeneous catalyst. How does a heterogeneous catalyst work? Well, it's kind of like figure 14.5 in your book. The catalyst gives your reactants a place to meet together. So it just gives them a place that's easy for them to hang out, and when it draws them close together, they react faster. So a heterogeneous catalyst is a different phase than your reactants. So these were gases, and our catalyst was a solid, and so it gave it a place to hang out, and that's how it made the reaction go faster. But sometimes a reaction is a homogeneous reactant. That's going to be the same phase. So how a homogeneous catalyst reacts is that it mixes with some of the reactants and it adds a step in there, but it makes the reaction go faster because it draws things together by doing an extra step. So if you look at the reaction mechanism on page 483, so again, this is a homogeneous catalyst. You have 2SO2 plus oxygen, and this is a gas, and this is a gas, and it turns into 2SO3, which is also a gas. So what I can do is I can add another gas, 2NO. It's a gas, so it's a homogeneous catalyst. What that does is it mixes first with the oxygen, and I'm not going to write gas, everything's a gas. And then that turns into 2NO2, but then that 2NO2 reacts easily with the 2SO2, and you're going to get 2SO3, which is what you want, plus the 2NO2 that you started with. Pull this over. Can't pull it over, so I'm going to have to turn this. Okay, so the important part is this is the overall reaction that I want. It turns it into a two-step reaction, but what you see here is that this is my catalyst, and I know it's my catalyst because it's here in the beginning, and it's here in the end, and it hasn't been changed. So a catalyst speeds up the reaction without getting used up. So if they give you two reactions next to each other and they say, what is your catalyst? You just need to look in the first part of the reaction and the last part of the reaction. You can ignore this middle part. It's magic that happens. And you say, which one hasn't changed? The one that doesn't change is your catalyst. So a heterogeneous catalyst gives you a place to hang out and reduces the activation energy and makes your reaction go faster. A homogeneous catalyst is the same phase. They're all gases, but it adds an extra step into the equation, but it makes it go faster. And you can tell which one it is because it will be in the beginning part of your equation and the ending part of your equation, and it won't have changed. Will not have changed? Whatever. So this test, as long as you know how to do your rate equation, which remember is rate equals K times the concentration of the first thing to an exponent, the concentration of the second thing to an exponent. If you can figure out what your exponents are from your trials, remember you only change one thing, that's really the hardest part of the whole thing. And if you got that, this test should actually be pretty easy. Just make sure to write all of your units in, because they're all different depending on what your orders are. It makes you have m squared or m to the 1, or maybe no m because your exponent is 0. And so that cancels out. All right, so good luck.